The first chapter that we have got in business mathematics is about functions. We have got, I think, 4 or 5 sections in that chapter. The first section that we have got is describing functions. Of course, if you do not know what a function is, later on we cannot find their domains, their range, differentiation, integration, or anything else, because every topic that we have got in business mathematics is depending on functions. Okay, so you have to well know functions, then we can do the other things that we need to do on functions. Okay, so what is a function in general? It says a function is a rule, so we have got a rule. Okay, we are talking about a rule that assigns to each object in a set A exactly one object in a set B. What does that mean? Here, if you look at that definition, we have got two sets of objects, set A and set B. Okay, we have got a rule that assigns each object, so each element in that set A must be connected to exactly one element in set B. So of course, let's describe this one, illustrate this one using a Venn diagram. For example, that is set A and that is set B. Okay, I have got 3 objects here and 3 objects there. Okay, that set A is called the domain of the function. Okay, that one is called the domain of the function, and that one is called the range of the function. Of course, if that rule is a function, okay, then we call set A the domain of the function and set B the range of the function. Okay, what does the rule say? It says each element in set A must be connected to exactly one element in here. Okay, if I do that one, okay, look, that element in here is connected to only one element there. That element is also connected to one there, and that one is connected to this one. So every element of set A is connected to exactly one element in set B. Since it is taking, or it is following the condition that is given in the definition of the function, so we say that that one is a function. Okay, this is a rule and that rule is a function. Let me give you another example, another Venn diagram, or let's say that I have got again 3 objects here, and let's say 3 objects there also. That one is set A, that one is set B. Let's see if I am making a rule here. Let's see if this one is a function or not. Look, if we come to the definition, it says every element must be connected. Okay, I have got 3 elements, all of the 3 elements are connected. But I have got something else here, it says exactly one object in set B. So each element must be connected to only one element in set B. If I look at this one, it's connected to only one element in here. If I look at this one, it is connected to only one element in set B. But if I look at that one, okay, let me name this one as A, B, and C, and that one 1, 2, 3. Okay, if I look at element A in the set A, it's connected to 2 elements. It has got 2 images. Can this one element have 2 images? No. Why? Because the rule says the points in A must be connected to exactly one element in set B. But since this one is connected to 2 elements in set B, so that one is not a function. Okay, that rule is not a function. You can consider a function as we can say a camera. Okay, a camera. If you have got a camera, okay, let me make another example of the Venn diagram, then I will talk about the camera. If I have got 3 elements here and 1 element in here, okay, that one is connected to that one is connected to this, and that one is also connected to there. I have got set A and set B. Is this one a function? Yes. Why is this a function? Because if you look at these elements, each element is connected, right? Each object in set A must be connected to exactly one object in set B. If you look at that one, it's connected to exactly one element in set B. That one is connected and it is exactly one element in set B. This one is again connected to only one element in set B. So since this one is having the rule of the functions, satisfying the condition of the function definition, so this one is also a function. As I told you, you can look at a function as a camera. If you take a picture alone, it comes out, your image or the photo that you have got will only have got your image, okay? If three of you and your friends, okay, let me say you and your friends are taking a picture, only one image comes out. That's also fine. It's totally fine. Three of you are taking a picture and only one photo will be your image, okay? But how about this one? If you look at this one, you are taking a photo, only one photo, and you will have two different images. Can this be possible? No, that one is not possible. So that's why this one is not a function, okay? So you can consider a function as a camera. If you're taking a picture alone, only one picture shall come out, okay? Each one taking a picture must have only one image, okay? If 3 of you or 10 of you are taking a picture together, okay, you can only have one image. But if you are taking a picture alone, you cannot have two different images, okay? So that is a function. We can also say that a function is a machine working as a machine. You are inputting something in and you will get an output. If you look at the camera, okay, the camera is a function. Why is it a function working? Because I'm inputting myself, okay? I'm inputting myself into there. I mean, taking a picture of myself, and of course, the image will come out. Whose image will come out? The image of me will come out, of course. So that one is a machine working. I'm inputting something, it will give me something out as an output. Or you can say that, for example, if I have got a machine like that, if you have got a blender, okay, we have got a blender here, for example, I'm inputting orange in here. What will come out? Orange juice will come out. Orange juice will come out. So that, what is that a blender in here? It's a machine, it's a function working. I'm inputting something, something else will come out. Okay, let's have the first example about functions. Let's come to the like mathematics definition of a function away from machines and cameras. We have got example 1.1.1. It says if I have got a function f of x that's equal to x squared plus 4, find what? F of 3. So in general, a function is defined like that. Okay, we can write a function like that. Or let me describe it here. We are writing a function as y is equal to f of x. Okay, because this one we can also write it as y is equal to x squared plus 4. There is no difference between f of x equal to x squared plus 4 and y equal to x squared plus 4. Okay, these two give the same definition for the function. Why? Because in general, functions are defined as y is equal to f of x. What are the x's that we have got? These are the inputs. Okay, I'm inputting something into the function, into the machine that I have got, and what will I get? I will get an output. Okay, the output is depending on the input, so that y is called a dependent variable. Okay, I have got two variables here, x and y. Let me write it here for you. Okay, x and y are variables. The x is independent variable, sorry. And the y is a dependent variable. Why this one is called dependent variable? Because it's depending on the value of x that I'm inputting into the function. Okay, here if you look at the orange juice is what? it is the y that I have got, and the orange is the x that I have got. Of course, if I am the orange juice is depending on the input. Okay, if I give an apple, if I put an apple into the machine, of course apple juice will come out, not orange juice. So that one is depending on the value of x when I am inputting it. That's why it's called a dependent variable, and that x is called an independent variable. It depends on what I am giving it to it, nothing else. Okay, we have got y is equal to x squared plus 4, and it says find f of 3. What is that 3 here? That 3 is the x that I'm inputting into the function. So let's see f of 3. Okay, f of 3 is equal to what? Of course, f of x is equal to x squared plus 4. So f of 3 is equal to 3 squared plus 4. 3 squared is 9 plus 4, and that is easy, of course, equal to 13, sorry, is equal to 13. That's a function. How do we input variables, numbers or anything, objects into the function, and how do we deal with it? Okay, let's move to the second example that we have got. We have got example 1.1.2. okay, it says f of x is equal to x minus 2 to the power of 1 over 2, or there is another way of writing this one. I can write this one as x minus 2 under the square root. Okay, in the example it's given like that, x minus 2 to the power of 1 over 2, but as you're familiar with, you've studied in college algebra, power 1 over 2 means square root, so that means x minus 2 under the square root. It says if possible, okay, because it may not be possible to find it. If possible, find f of 27, find f of 5, f of 2, and f of 1. So what's required from us? The function is given to us. It says input those numbers and see if it is okay to input it into that function. Okay, let's start with 27. Okay, f of 27. So instead of each x, we are putting 27. 27 minus 2. Why? Because the function that we have got is x minus 2. So x minus 2, instead of the x, I'm putting 27. So that will be 27 minus 2. 27 minus 2 is equal to what? Is equal to 25 under the square root, and 25 under the square root is equal to 5. So it was possible to find f of 27. The second requirement, let's see if it would be okay if I input 5 instead of the x that we have got. 5 minus 2 under the square root is equal to what? Is equal to square root of 3. You can leave it like that. You do not need to use calculators. Okay, so you just simply leave it as root of 3. Root of 3 is, you cannot calculate it yourself. You need a calculator, but leave it like that. That would be fine. So it was possible to input, instead of every x, 5. Okay, let's find 2. F of 2. F of 2, that means 2 minus 2 under the square root. 2 minus 2 under the square root is equal to what? It's equal to 0. 0 under the square root is coming out as 0. So it was also possible to find f of 2. Let's come to f of 1. That will be 1 minus 2. 1 minus 2 is square root of minus 1. Can I take minus 1 out of the square root? No. In real numbers, we have got no minus 1 getting out of a square root. It's something undefined. Okay, so it is not possible to find or to get f of 1. Okay, we cannot find f of 1. Why? Because when we are putting it instead of the value of x, we will get a negative number under the square root, and negatives under square roots are not defined. Okay, let's move to another example. Example 1.3. we are given a piecewise defined function. What's a piecewise defined function? If you look at the functions that we have stated previously, this function and that function, it's only one piece. What does that mean, only one piece? That means f of x is only given to me as x squared plus 4. This is the only definition for the function that I have got in here. Okay, but if the function is defined in more than one piece, it's called piecewise defined function. So what is the piecewise defined function that is given to me in here? It is f of x that's equal to 1 over x minus 1 when x is less than 1. Okay, so if the values of the x that are given to me are less than 1, 0, -1, -2, and those numbers, I will use that piece of the function. And if the function is defined as 3x squared plus 1, if the numbers, the outputs, the inputs that I have got are greater than or equal to 1. So if the numbers that I have got are greater than or equal to 1, I will use that piece of the function. What is required from us? It says find f of minus 1 over 2, okay, f of 2, and f of 1. 3 requirements for us. So let's solve the function. Input those values. Let's see what will we get. F of -1 over 2. -1 over 2, instead of every x, we are inputting -1 over 2. -1 over 2 is greater than 1 or less than 1. Of course, it is less than 1. Since it is less than 1, so we are putting that number instead of that x, okay? We are using that piece of function. So that will be 1 over -1 over 2 minus 1. That would be easy for you to solve because you've studied this one in college algebra. We have to equalize those denominators. That will be 1 over -1 over 2 minus 2 over 2. We have to equalize this denominator with that one. So that one is 1 over -1 minus 2 is -3 over 2. This one will be flipped, okay? So that will be -2 over 3, and that is the result. Why did we use the first piece? Because the x that we have got here, okay, that one, is less than 1. Okay, it is less than 1. Okay, let's move to the second one. We've got f of 2. 2, the number that we have got is 2 that we have to input into the function. 2 is greater than 1 or less than 1. Of course, 2 is greater than 1, so we are using that piece of function to put the 2 in. So that will be 3 multiplied to 2 squared. We are putting it instead of the x that we have got there. So 3 multiplied to 4 plus 1. 3 multiplied to 4 is 12 plus 1 is equal to 13. Okay, the third one, we've got f of 1. That's equal to what? In which piece shall we put 1? This part of the function or that one? If you look, we have got equality here. What does equality mean? That means the x's that I have got are equal to 1 or greater than 1. Look, the 2 was greater than 1, but if it is also equal to 1, I can use that piece of function, not this one, because here I do not have the equal sign, so I'm not using that function for that one. Okay, I'm using that piece. So that one will be 3 multiplied to 1 squared plus 1. So 3 plus 1 is equal to 4. Okay, it is possible to find it, but we again use the second piece of the function. Okay, so that is a function, the definition of a function, and what is an input, what is an output of a function, how does it work, what is an independent variable, a dependent variable. That was a general description for a function. Now we are coming to the domain of a function. What is domain? Okay, domain is the set of all numbers. Okay, let me write it for you. Set of all numbers for which the function f of x is defined. What does that mean? Of course, the numbers, the set of numbers that I have got is the set of real numbers because we are working on the set of real numbers. What does that mean? That means if I have got a function, I will check if I could input into that function which numbers. The numbers that I can input into the function and doesn't make a problem for me while I'm inputting them into the function, these ones are called, I'll put them into a set, okay? And I will call that set the domain of the function, okay? Let's move to the first example. Of course, when we are coming to examples, it would be easier for you to understand. Example 1.1.4, it says find the domain, okay? Or I will simply write the domain is equal to what? The first function that we have got is f of x, that's equal to 1 over x minus 3. If you look at this function, I can put every number instead of x, okay? I can put, for example, 1. If I put 1 here, it will be 1 over 1 minus 3. That will be 1 over minus 2. 1 is not making a problem for me. If I put 0 into that function, 0 is not making a problem for me. If I put negative numbers, positive numbers, rationals, irrationals, nothing is making a problem for me. What is the only number that is making a problem for me? If I input 3 instead of that x, okay? Why 3 is making a problem for me? Because it becomes 3 minus 3. 3 minus 3 is equal to what? Is equal to 0. If I get 0 in the denominator, is that possible? No, it's not possible. It's something undefined. So we say that I can input, okay, the domain of the function is equal to what? Is equal to the set of all real numbers. That means I can input every number into that function, except which number? Except 3. Okay, that one means except. Or you can write it as r minus 3. That means I can put every number except 3. Why I cannot put 3 into that function? Because 3 makes it equal to 0, and 0 is undefined when we are talking about the denominators of the functions. Okay, the second example that you have got, it says f of x is equal to x minus 2 minus 2. What is the property of square root? Does it take negative numbers, positive numbers, or what? Of course, when we are talking about square root, it is taking only positive numbers. Okay, it's defined only for positive numbers. As we previously said in the example, if we get a negative under the square root, we cannot solve it. So, what is the condition for square root? I say that whatever I have got underneath the square root must be something greater than 0. What does greater than or equal to 0 means? That means something positive. That thing must be positive, then I can deal with it. Then I can find the value of that function. So x minus 2 must be greater than or equal to 0, means something positive. Let's come and solve that one, okay? So x minus 2 is greater than or equal to 0. I'm taking the 2 to the other side, so x is greater than or equal to 2. What does that mean? That means for that function, the domain of the function is equal to 2 to infinity. Or that is directly, I can say that it is the domain of the function. What does that mean? That means I can input only numbers that are equal to 2 or greater than 2. If I put 2 into that function, will it make a problem for me? No, because 2 minus 2 is equal to 0. 0 comes out of under the square root, so that will be fine. If I put 3, because x is greater than or equal to 2. If I put 3 into here, will it make a problem for me? No. 4 also will not make a problem for me. So those numbers that are greater than or equal to 2 will not make a problem for the function. So I will call those numbers the domain of the function. How about if I put 1 into this function? What will I get? 1 minus 2 is equal to minus 1. Minus 1 is something undefined. That's why I cannot input numbers that are less than 2. Okay. Here, no more examples are given for the domain of the function, but I feel like you need more examples for that because their students are always weak in finding the domains of the functions. So I'll give you more examples myself. Okay, if I have got f of x that's equal to 1 over x, I'll start with the easy ones. 1 over x, what is making a problem for me here? Look, when you're searching for the domain of the function, what will you do? You will search for those numbers that are making a problem, and then, like, let me say, we are kicking them out of the set of real numbers, okay? Like if you have got a class, okay, full of students, those students that are making noise in the class, if I let them go out, those that are remaining in the class are called the domain of the class, okay? So I let the naughty students get out of the class. The remaining ones are called the domain of the class, okay? Here, when we are trying to find the domain of the function, we are doing the same procedure. We are looking for those that are making problem, okay, that are naughty students, and then we will take them out of the real numbers. Here, what is making a problem for me? 0 is making a problem for me. So I will say the domain of that function is equal to the set of all real numbers except 0, or I said you can write it as r except 0. This gives the same meaning, okay? Why I said except 0? Why I threw 0 out of the real numbers? Because 0 is making a problem for me here, or other numbers are not making a problem for me, so I'm writing them as they are. Okay, if I have got f of x that's equal to 1 over 5 minus x, what is making a problem for me? What's making denominator equal to 0? Let me write for you domain of f. 5 is making a problem for me, okay? So the domain of the function is equal to the set of all real numbers except 5, okay? I threw 5 out of the domain of the function. Why? Because it is a problem maker. Let's give another example. If I have got f of x that's equal to 1 over x squared minus 4. What are the numbers that makes this one equal to 0? Look, I'm searching for those that are making the denominator equal to 0 and then kick them out, okay? So x squared minus 4 is equal to 0. I have to solve it. Some of the questions need to be solved, okay? Or if you can guess it, you can directly write the answer for me, but it would be better for you to do everything step by step, because when you're doing the quizzes, the assignments, everything is required from you to do step by step, please, okay? I will not give you any mark for giving me only the solution for the problem. I need everything to be done step by step. Okay, so if you look at this one, I can say x is equal to, x squared is equal to 4. I'm taking this 4 to the other side, then taking the square root for both of the sides. X is equal to plus or negative or positive 2. So what is making a problem for me? Positive 2 is making a problem for me because it makes the denominator equal to 0, and negative 2 is making a problem for me because it makes the denominator equal to 0. So what is the domain of that function? The domain of that function, I can input every number except which numbers? Except negative 2 and 2. Why? Because these ones are problem makers for my function that is given there. Okay, let's give another function, f of x that's equal to 1 over, for example, x squared minus 3x. Okay, can you guess this one? Which numbers are making a problem here? Of course, 0 is making a problem, and I have got also another number that is making a problem for me. So what will I do? I will think of those numbers that makes the denominator equal to 0, and I will solve it. How can I solve this one? Of course, you've studied this one in college algebra by factorizing it and then solving it. So 1x is common in here. I will take 1x out. Here x remains minus 3 because I've taken x out here. So either x is equal to 0 or x minus 3 is equal to 0. I've got multiplication of this one with that one. So either this one is equal to 0 or that one is equal to 0. So x is equal to 0 or x is equal to 3 because I'm taking that one to the other side. I have got two numbers that makes the denominator of that function equal to 0. So what is the domain of that function? is equal to the set of all real numbers, I can input everything except which numbers? 0 and 3, because these ones are problem makers for my function. Okay, let me give you another example. F of x is equal to, for example, let's say 2 minus x. Look here, the above example I have got x minus 2. Here I'll give you 2 minus x. Whenever you see a square root, how will we solve that question? We will say the underneath of the root must be something greater than or equal to 0. Okay, so I will come and solve this one. Okay, 2 minus x is greater than or equal to 0. I'll take x to the other side, so 2 is greater than or equal to x. What does that mean? Or let me write this one in another way if you cannot understand it. I can write this one as also x is less than or equal to 2. 2 is greater than x, or you say x is less than or equal to 2. Gives me the same meaning. So which kinds of numbers I can input into that function? Those numbers that are less than or equal to 2. So I can input 2 into that function. For example, 1, 0, minus 1. And those numbers will make what? Will make my function defined. But if I input any number that is greater than 2, it will make the function that I have got something undefined. Okay, so that one is called what? I will simply call this one the domain of the function. It includes those numbers that are less than or equal to 2. Okay, let me give another example. F of x is equal to 1 over square root of 2 minus x. How can I solve this one? Look, I have got what here? Two things mixed up together. The square root and I have got a rational function. Okay, these two, it's like they're mixed up together to make this function for me. How can I solve this one? Here, if the function that I have got, if I get 0 for this one, okay, look, greater than or equal to 0. Even if I get 0, I have got no problem for that. I can still have 0 because it's in the numerator. But can I have 0 in the denominator of a function? Of course, I cannot have 0 for the denominator of the function. So how can I solve this one? I will solve it simply by saying that this expression must be something greater than 0. Okay, I cannot write it equal to 0. Why? Because if I get 0 from here, I will get something undefined. So what's the difference between solving a square root in the numerator and square root in the denominator? It's only this equal sign. The other steps are only the same. Okay, taking that x to the other side, so 2 is greater than x, or I can say that x is less than 2. What's that called? That's called the domain of the function. If you look at the difference between this one and that one, what is it? Here I say the numbers must be less than or equal to 2. That means I can also put 2 into that function. Okay, if I put 2 into here, what will I get? 0. Okay, 0 is fine, totally fine for the numerator. But here I do not have the equal sign. Why? Because I cannot input 2 into that function because it gives me 0. 0 in the denominator is something undefined. Okay, so that's all about the domains of functions. You can have more examples. For example, if I have got, let me give you one more example. F of x that's equal to square root of x. How can I solve this one? It is only taking those numbers that are greater than or equal to 0. Whatever you have got under the square root, just let it be something greater than or equal to 0, and it will be easily solved for you. Whatever you have got in the denominator, set it equal to 0, and then remove those numbers from the set of real numbers. You will get the domain of the function. So what is the domain of the function? Is equal to set of all x that are greater than or equal to 0. Okay, simply it's just the positive numbers including 0. That's about the domains of functions. Only one example was given in your course material. The others, we did it ourselves. Okay, let's move to example 115. It's a word problem, but it is an easy one. Let me write it for you. Okay, what we have got here is an example. It says, suppose that the total cost in dollars, so the cost, we have got cost, okay, in dollars, of manufacturing Q units of a certain commodity, that means a certain good, certain thing, okay, is manufactured, What is the cost? It is C of Q that's given in that description. Q to the power of 3 minus 30Q squared plus 500Q plus 200. Okay, what is Q? Q is the amount of the units. For example, if I have got, for example, that manufacturer is manufacturing laptops, okay, Q is the amount of laptops. For example, 5 laptops are manufactured, so instead of Q, what will I write? I will write 5. Okay, what is required from us? It says compute the cost of manufacturing 10 units. So I have got 10 units. Okay, I have got 1, 2, 3, 4, 5, 6. Okay, I have got 10 units manufactured by that manufacturer. It says find the cost of manufacturing all of 10 of them. Okay, how can I find it? How many units have they manufactured? 10 units. So instead of Q, I will simply write C of 10, okay, because 10 units have been manufactured, is equal to 10 to the power of 3 minus 30 multiplied to 10 squared plus 500 multiplied to 10 plus 200. You simply calculate this one and you will get $3,200 for that. Okay, so the cost for manufacturing 10 laptops is equal to 3,000, for example. Okay, of course I'm saying laptops, is equal to 3,200. Let's move to the second requirement. Okay, Q is the amount of units. Okay, compute the cost of manufacturing the 10th unit. What does that mean, the 10th unit? Look, in the first one I said I have got 10 laptops. I'm finding the cost of 10 of them, but here it says find the cost of only the 10th one. Okay, it doesn't say find the cost of the first laptop, second laptop. It says only the 10th one. What is the difference between the 10 units and the 10th one? Here I'm finding the cost for 10 laptops. Here I'm finding the cost of only one laptop, but the laptop that I'm finding the cost of is the 10th unit. Why it doesn't say the first unit? Of course, manufacturing the first unit is different from the 10th unit. Why? Because if you have got a company, a factory, when first you're turning it on, for example, it starts to work, it needs more energy, it needs more electricity, more power till it works, till it starts working. It costs more for the first unit. Okay, but then when it is working properly, it takes inertia. It is working continuously. When it starts working continuously, of course, the more it manufactures, the less the cost will be, of course. Okay, definitely the cost for the first one will not be the same as the cost of the last one. The first one will cost more than the last one. Okay, so how do we find this one? We will find it as, okay, C10, okay, minus C9. What does that mean? That means I'm finding cost of 10 of them minus the 9th of them. Okay, so what will I get? I will get the cost of the last laptop. Okay, so that one I have found the C of 10, that's equal to 3,200 minus, then I'm putting 9 into there, that will be 9 to the power of 3 minus 30 multiplied to 9 squared plus 500 multiplied to 9 plus 200. When you're doing that subtraction, it will be $201. Okay, so the cost for manufacturing the 10th laptop, only the 10th one, not the others, is equal to $201. Look here, I found the cost of the first laptop. When you're finding it, it will be $671. Look, the difference between the 10th unit and the first unit is very huge. As I told you, the first one, since it needs the generators and factory start to work, it takes more power, more energy, so the first one will of course definitely cost more than the 10th unit.